This is my solution for Palmer Quarters Pico Series Lesson 100. Do the sweeping servo inside of a class. On the left you see my setup. I just have one servo, and on the right is my code. And before I start, take a look up here at the VLC icon. It's December 23rd, and I think they've changed it slightly. Kind of cute. All right, so in the source, I have the definition from the lesson 99, essentially. The other stuff I put in a class. The picow program is the same one I had before. Here comes the class definition. It's only going to handle one servo. When you create it, this is like a Java constructor, the underscore init underscore. You pass in 4 parameters. The servo ID, which is really the state machine number, the period in milliseconds, which GPIO pin controls the servo, an initial angle for the servo arm. These first 3 lines just verify the servo ID that comes in is a number between 0 and 7. It gets saved in a private variable. The double underscore variable names are private. That means that outside of the class you can't see them. It would require getters and setters. So I save the values in numbers, but I take the period that the user gave me in milliseconds and save it in microseconds. Save the pin, and then make sure the angle that they passed in is between 0 and 180 degrees. The servo is initially off, and this is a flag that will be used. Setting it to false means, as far as the class is concerned, the servo is off, or the state machine is off. These are the numbers that were calculated in the previous lesson for the slope of the line that converts angles to PWM values. Scrolling down, here's the definition of the state machine using the variables. I may have to scroll right a little bit here so you can see it all. I do the same presets as before. Take the period, get it into the OSR, and then copy it to the ISR. Get the first angle, convert it to a pulse width, put it into the OSR, and also copy it to the X register. I have a function that's used while it runs to convert an angle to a pulse width value. Same one I had in my previous lesson, just using these class variables. And you'll notice this function also begins with 2 underscores, so it's a private function. Outside of the class, no one knows about it. This next function is public, so someone that creates the class can call this function. And it's a function that the user would call to set the angle. So the angle comes in, we make sure it's between 0 and 180, and now we convert that angle to a pulse width and then do the put to the state machine. Now, in that constructor, you'll notice that the state machine was not activated yet. So here's another function that the user will call to start the state machine. They don't know that. They're starting the servo as far as they're concerned. It makes sure it isn't already active, activates it, and now sets that flag to true so that it is active. Here's another function that will inactivate the state machine, but the users, as far as they're concerned, they're stopping the servo. This last function that's within the class is like the Java toString function, double underscore string at double underscore, and I just converted some of the fields that were used in the constructor and returned that. So I just added that. So here comes the user code, not much of it. Create a servo object, pass in state machine, well, servo ID, period, GPIO pin initial angle. This print statement invokes this toString method. And we'll just see, I just did that for fun. Here's where we start the servo, so that calls this function here, so that will activate the state machine. And then we enter a loop. I'm only going to rotate it or sweep it 3 times. So let me run it. Watch the servo. There it goes. Here's 1. And then 2. And then 3. And it stops. And notice right here that print S, this is what it printed out. So that is the end, but I didn't really like having to have the servo class in line. As a Java programmer, I define my classes separate from programs that create the classes. So I decided to find out how to do that. I extracted out the servo code. So this is from that program. This is exactly just the servo class. That's the end of it. And then I created another program, which was just the ending part of the homework assignment. And I have a line now from servo import capital S servo. So that should import this one. And here's the program. That's the same as what's at the bottom. Now, if I were to run this, it would fail. And the reason is this program is going to run on the picow. This file exists on my PC, which is a Raspberry Pi. When this program runs, it's on the picow, it won't have access to this file. And I discovered that by trying. So what you have to do is download this file to the picow. And you do that by File. Let me make sure I'm in it. File, and I'm going to save as. And I'm going to save it on the picow. And you'll notice I already have it down there. So I'm going to cancel. And I'll explain how that got there after we run it, see that it works. So now I'm going to run this program. Watch the servo motor. It's going to do its 3 rotations again. 1, 2, 3, and it's done. All right, so I will confess that I did not know how to get the file down to the picow and how to manage files on the picow. I found a YouTube video, of course, that had a real 4-minute tutorial that showed it. So I've moved my cursor down into the prompt area, and I'm going to do a few commands. And I am on the picow down here. And I'm importing something called OS. And I'm going to do OS, no, I guess it's dir OS. And these are commands that you can run down on the picow. I can remove a file. I'm just looking across here. I can change directory. I can get the current directory. I can make a directory. I can remove a directory. See, I can list a directory here. Well, let me do that. And out on the root, I have that servo.py program. So when that program that's on my Raspberry Pi, the one that's on the upper part of the screen here, was downloaded to the picow, this import statement can work because the servo.py program source code is down there. Okay, that's it. My VLC icon says Merry Christmas. Thanks for watching.